So now what happens is it begs the question, how do we find the area under the curve? If I was to look at a very, very simple curve, the way that I'd find the area under it is, let's say if we just had some constant line right here. So if I looked at this constant, well, finding the area under this from A to B would actually be relatively simple. All that I'd do is I'd figure out what the height of it is, and then I'd multiply that by the length. And we'd get, well, the area would equal the length multiplied by the height. So that's nothing too crazy. If I moved and if I looked at a slightly different structure, so let's say we had something linear going on right there. Sorry about the tremble in my hand. But again, I look at this from A to B, and the area under of this one would just be area equals, and I'm going to label that as length, label that as height again. So it would be length multiplied by height all over 2. Well, that's pretty simple. But now what happens if I have a curve that's slightly different? So how would I find the area if my curve instead looked something like this? And, this would be pretty hard. Now, some of you guys may say you may try to do it using the property of exclusion. So what you do is you'd find the area of this piece, and then you'd find the area of everything. And then we'd just minus that red area from the entire blue area. And in some cases, exclusion could work, but it comes with the problem that I don't necessarily know the curvature of this. If it's perfectly curved, so if it's circular, that works. If it's elliptical, so not quite circular, a bit more elongated, well, then we'd have to start using elliptical modeling, and we'd have to try to find the areas of ellipticals, and that would actually get a bit more confusing. So what we're going to do is we're going to use a method of estimation. Now, you guys really don't see the mathematical side of estimation, especially with the way the curriculum works right now. You're made to estimate many times throughout elementary, junior high, and high school, but the estimation always seems kind of moot because the numbers that you're estimating, you can very easily find the exact values for. So a lot of times people are just like, well, estimation, what's the point? But the point of estimation mathematically is that if we don't completely know how to find something, what we'll do is we'll continually try to estimate, and we'll continually try to guess, and then we'll look at all the guesses we have and see if there's a way we can wrap those up together to come up with a perfect guess, or rather a guess that's going to be right all of the time. Well, let's see how to do this for the area under the curve. So again, I just draw out my general curve right here, and it's going to look something like this. Now, just for funsies, what I'm going to do is I'm going to try my first estimate. And my first estimate, I'm just going to take and I'm going to draw a rectangle under this curve. Now, there's a bit of science as to where I draw the height from it, but we'll look at this right now. We'll say, well, I've drawn this rectangle under the curve. Now, is this an estimate? And the answer is yes. Is it good? No. The answer is no. That's a terrible estimate. There's so much area under there that we're not actually looking at. So I'll draw out my curve again, and don't worry, I will eventually stop drawing out the curve. So I draw out my curve again, and instead of one rectangle, what I'm going to do this time is I'm going to draw 2 rectangles. So at about the halfway point right here, we'll stop, and then I'll draw another rectangle, and then we hit right there. Okay, so now I have 2 rectangles. Back to the old question, is it an estimate? Yes. Is it good? No. But we have one other thing that I'm going to ask, and is it better than the last one? And yes, this would actually be a better estimate than the last one. So again, what I'm going to do is I'm going to draw my curve out again. And this time, what we're going to do is I'll jump up and I'll use 3 rectangles, and I realize I'm not drawing the same length on this curve. But, so now what I've done is I've created 3 rectangles. And again, is this an estimate? Yes, it is an estimate. Is it a good estimate? No, it's not a good estimate. But is it better? The answer is yes. And what we can continually do is I can continually draw more and more rectangles under this. So as I continually draw more and more rectangles under this, I get better and better estimates. And right here, I'm going to draw a lot of rectangles under this. And as I draw more and more rectangles, you guys can sort of see that the missing space, or that little missing space, gets less and less and less and less. So my best estimate would be infinity rectangles. So if I could find a way to draw an infinite number of rectangles under this and then find the area of each of those rectangles, that would give me my best estimate. Now we're going to get to the mathematics of this. I just kind of wanted to set this piece up first. The next lesson, what we're going to do is we're going to look at how I look at this idea and then put this into mathematics to actually come up with an exact answer.